Happy evening, students. Let us continue today with the oblique incidence as we discussed in our last class. Okay, we are going to solve one question based on oblique incidence, and it's something like this. Here is a source, and we are making two slits over here. One is like this, and one is like this. Here is slit, and this is a slit, and there is a screen here. Okay, this is S1, you can say, this is S2, and this is the center of the screen. Now the question in this case, as it's oblique incidence, is the central maxima forming here? Is the path difference because of the two 0 here? Answer is no. Why? Because S1 and S2 are not in same phase. They have a different phase. Now the reason for that is what? Because the main source is S. From here, this wave is traveling more as compared to this one. Okay? So these two sources are not in same phase. So even if from here onwards the waves are traveling same distance, but still here path difference is not 0, so central maximum is not here. Okay? What are the other things given to us? This is given as D, this is also D. And all our general terms like capital D is a lot more than small d, this is capital D. And lambda is very small as compared to D. Okay? All these things are valid. Now what we have to do? We have to find where is central maxima. Where is central maxima? We know it is not here. Now where it is then? Above this or below this? Above this. Why? Why? Because we want to find a point where we can say that the net path difference is 0. We already know that on the left side of this slit, already this one has traveled more. So on this side we need to make it travel less and make it travel more, then only we will be getting the central maxima. So let's assume at this point P we are going to get central maxima. Let's join this one. Okay, so here we are going to get the central maximum. Alright, now what we want for central maxima? We want that delta x for central maxima need to be 0. Now what is delta x in this case here? This case is S1 plus S1p minus S2 plus S2p. This needs to be 0 for central maximum. Okay, now what is here? SS1 minus SS2 I will be writing first. SS1 minus SS2 plus S1p minus S2 equal to 0. Now what is this? You can see that SS2 actually is D and SS1 is what? This is the right angle triangle you can see over here. Okay, so what this is going to be? This we can write as D square plus D square. Okay, so this is SS1. So let me keep it over here. That is D root 2. This is root over 2D square. So we can write this as D root 2 minus SS2. That means minus D. Okay, S1p minus S2p. Now what we can do? We know that what we used to do over here. Drop a perpendicular from here to this one. Say this is theta. Okay, so this we will be getting as d sine. Okay, so S2p minus S1p. What is this? S2p minus S1p is d sine theta. What is written over here? S1p minus S2p. So I can write here minus d sine theta equal to 0. Okay, d sine theta, take that side. So d into root 2 minus 1 equal to d sine theta. Okay, now if this is valid, as is given is valid only, what we can do? We can join this with this again. And if this is theta, this is also theta. We know it already. So in this triangle, I can write tan theta theta equal to y by d. Tan theta equal to y by d. And since its value, lambda is very very small as compared to d, I can say sin theta and sin theta will be equal because theta is very very small. So in place of this sin theta, I can write y by d. So what is going to come then? Let's see. So d into root 2 minus 1 equal to d. In place of sin theta, what I am going to write? Y by d. This d gets cancelled. Y value came out to be root 2 minus 1 into d. This is the position of central maxima in this particular question. Okay, is that clear? Let's go on to the next question then. The next question is a different type of question but very important question because these kinds of questions are asked in the exam. Okay, what is the question here? Two slips in YDAC, that is Young's double slit experiment, have width in ratio of 1:4. Find the ratio of intensity. Find the ratio of intensity at maxima and minima. Okay, this is the question. Now what is given? Two slips in YDAC have width in the ratio of 1:4. Width of slit is in this ratio. Okay, let's see the solution, what we can do. Now when we talk about maxima and minima, maxima means root I1 plus root I2 whole square. Minima means root I1 minus root I2 whole square. Okay, so I1 and I2 we require if we want to find maxima and minima. So I1 by I2 or in general intensity is directly proportional to area of the slit. Intensity in general is proportional to area of the slit. So if I write I1 by I2, I can write this as L, the length of the slit, into width of the slit. That means I am considering this as a rectangle. If you remember how I told you the slits are, take a cardboard, okay, take a razor and cut it like this with a razor. Very thin line. So thin line thickness will be there and length will be there. So it will be kind of a rectangle. So what will be its area? L into B. So I have written L into B1. Same way the other one, L into B2. Okay, this gets cancelled. B1 by B2 is given to us 1 by 4. Okay, so root I1 by root I2 then 1 by 2. Okay, then what I do? Root I1 plus root I2 by root I1 minus root I2. Component 2 and dividend 2. That means 1 plus 2 and 1 minus 2. But here we are not looking for the sign. Okay, so root I1 plus root I2. Root I1 minus root I2 here. So we are getting 3 by 1. What we want? I maximum means what? I maximum means root I1 plus root I2 whole square. And I minimum means what? Root I1 minus root I2 whole square. So square then this 9:1. That will be our answer. Okay, so if any question is given in which width is given, width of the slit, this is the way to do it. Okay, let's see another question then. Okay, so there's a question here, S1, S2, and this is D. D is given to you as 150 meter. Okay, and both the sources are producing frequency of 1 megahertz. microwave frequency. Okay. And it's given that the maximum intensity because of their interference. Maximum intensity due to their interference is I naught. Okay. So here is the screen. This is the central maximum. And some other intensity if we write. Take this as point B. Okay, so intensity is actually a function of theta. So question is asking us, find intensity when theta is 0, 30 and 90. This is theta, okay? If this theta is 0, then what is the intensity? If this theta is 30, then what is the intensity? And if this theta is 90, what is the intensity? It's a slightly different kind of a question. Frequency is given in that. Wavelength is not given. So first thing that we will do is find wavelength, because wavelength is what we require. What we know? Speed equal to frequency into wavelength. Microwave. It's a part of light or sound? It's a part of light. So light speed 3 into 10 to the power 8 meters per second. Frequency 1 megahertz. That means 10 to the power 6 into wavelength. What we are getting? 300 meters. This is the wavelength. Okay. Wavelength is 300 meters. Okay, fine. So to get the intensity, what we require? Phase difference. And to get the phase difference, we require path difference. Correct or not? So if this is theta, we know that at any point, this will be the path difference. And if this is theta, this is also theta, we know. This is delta x, and delta x definitely is d sine theta. No doubt about that. Delta x is d sine theta. Okay. Then, what is phase difference? Notice 2 pi by lambda into delta x. That means 2 pi by lambda into d sine theta. Okay. Fine. So delta phi is a function of theta because. Another thing in the question is given to us is the maximum intensity is I. Okay. Remember that, because with that only we will be finding out the intensities at other places. So maximum intensity is phi. When we get maximum intensity? When the phase is 0. Okay. So if I consider both these sources are having same intensity, let's say that I1, then the maximum intensity, I resultant, is normally 4I cos square pi by 2. Correct or not? But in place of 4I, he is saying maximum intensity is I only. So it's I. When you are going to put phi equal to 0, I resultant is I. Okay? Remember that. That's what the question is saying. Come back to this point. Okay. So we know that I resultant is I cos square pi by 2, and phi is given to us by this. 2 pi by lambda d sine theta. Now, first question. When theta is 0, put theta here 0. So sine 0 is 0. That means delta phi is 0. That means put phi 0 over here. Resultant intensity is coming I. Did you understand? If theta is 0, put sine 0 here. It becomes 0. That means delta phi also 0. And this is delta phi only. So if delta phi is 0, then cos square 0 means 1. So answer is coming I. So at theta equal to 0, resultant intensity will be I only. Okay. Let's go for the next one. Theta is 30 degrees. Let's put theta is 30. See what's coming. 2 pi by lambda. Now lambda is how much? 300 meters. And d is what? D is 150 meters. That means lambda by 2. D is lambda by 2. So let's put it here. 2 pi by lambda. D is lambda by 2 sin 30. That means 1 by 2. This gets cancelled. This gets cancelled. It's pi by 2. So delta phi is coming pi by 2. Delta phi is coming pi by 2. So put it over here. I resultant is equal to I cos square. Delta phi is pi by 2. Pi by 2 by 2. That means pi by 4. Cos pi by 4. That means cos 45. Cos 45 means 1 by root 2. 1 by root 2 square. That means 1 by 2. So what we are getting resultant intensity? I by 2. At theta equal to 30 degrees, the resultant intensity is coming I by 2. Okay. Then last one, theta equal to 90 degrees. Okay. Theta equal to 90 degrees. Put 90 over here. See what comes. So delta phi equal to 2 pi by lambda into lambda by 2 sin 90. Sin 90 means 1. So if this is 1 here, then what I am getting? Lambda gets cancelled. 2 gets cancelled. It is pi. So it will come I cos square. What will come? So IR equal to I cos square phi by 2. So what is delta phi here? Delta phi is coming pi. So pi by 2. So cos pi by 2 is 0. Cos square pi by 2 is 0. So answer is 0. So intensity will come 0. Do you understand? If theta is 0, we got intensity I. Theta is 30, we got intensity I by 2. Theta is 90, we got intensity as 0. How we got it? We calculated delta x, from there delta phi, and then we are going to put it into this formula. Is that clear? Okay. And if suppose one more question is asked, what is this I1? Can you find I1? Yes, we can. How? Because we know that if the two sources are of the same intensity I1, then I maximum should be equal to 4I1. Maximum intensity should be 4I1. Okay? How? You can find it if you want. I1 plus I2 2 root over I1 I2 cos 1. When we are talking maximum, means this phi needs to be 0. That means 1. So since this is I1 and I2 is also I1 plus 2 root over I1 I1. This is 1. So this is 2I1 and this is also 2I1. So maximum intensity needs to be 4I1. But in this question, maximum intensity is given what? I. That means this 4I1 actually is given to you as I. So what is I1 then? I1 is I by 4. Is that clear to you? Okay. So each source is having what intensity? I by 4. Okay. Right then. Let's go for the next concept now. Next concept that we have is optical path length or optical path. Okay. What is this? Let us see. Optical path. Okay. Now suppose that one wave is moving in air. This point I am saying is A and this point I am saying is B. There are 2 points. Let's say the separation between them is C. Okay, they are part of the wave. One wave is moving like this. Okay, now I want to find what is the phase difference between the two. What is the phase difference between 2 points? Delta phi AB. What is the formula? Formula says K delta x. What is delta x actually? Path difference. What is the path difference? What is the difference between the two? It's T only. So delta phi AB will be 2 pi by lambda into T. Correct? Now if the same wave passes through a medium, slab, you can say, a glass slab of the thickness T. Okay. Now in this one, I take 2 points over here, A dash and B dash, and its coefficient of refractive index consider as mu. Now again, same thing I want. I want what is the path difference, or rather phase difference between A dash B dash, delta phi A dash B dash. How to write? Again same. K dash delta x. What is delta x? Same T. K dash into T, but what is this K dash? K dash is 2 pi by, we'll be writing lambda or something else. The wavelength, when the wave moves into the different medium, or a ray goes into different medium, what happens to wavelength? Or what happens to the speed of light? Speed of light decreases. When light moves into the denser medium, the speed of light decreases, right? Frequency remains same. So wavelength also has to decrease, because speed is directly proportional to wavelength. When speed, you talk about the light goes into a different medium, then speed becomes c by v. So then wavelength also becomes, so in this case also, what is wavelength? Lambda by mu. So here lambda by mu, so that mu will come over here and become like this. Okay, so what is the phase difference here? 2 pi by lambda into mu t. And this mu t is called optical path. This mu t is called optical path. And this 2 pi by lambda, now I can call it k. And k is what? Propagation constant of air. Okay, so what is the meaning of this basically? What is this mu t? Mu t basically is the distance here traveled by the wave in the medium is equivalent to mu t distance traveled by the same wave in air. Are you able to understand? This is the equivalent distance in air. If the same wave I am going to take in air, it will travel how much? Mu t. So who has traveled more? This is traveling as compared to air. Understanding? This is 2 pi by lambda when I am writing. This is k for air. Okay? So when this you are going to take in air, this much is the path traveled by the wave. Here wave is traveling more path. This is corresponding to how much path in air? Mu t path in air. So what is the path difference between the two? How much is the path difference? Let's see. In air, it is traveling t. In medium also it is traveling t. But this is corresponding to mu t distance in air. So what is path difference then? The path difference is mu t minus t. That is mu minus 1 into t. Able to understand? When you are going to put a slab, then the path difference that is creating as compared to air is mu minus 1 into t. Okay? Let us see how to use that. Suppose that I am going to introduce one slab, very thin slab. Okay. Suppose this is S1 and here is S2. Okay, and there is a screen over here. Now I introduce a slab over here. Mu, this is T. Again my question is same. This is the center point of the screen. Whether it's going to be central maxima here. When the rays are reaching over here, are they traveling the same distance? Answer is no. Geometrically it appears like they are traveling same distance, but we know that because it's passing through the slab, it is traveling little more than the rays would have traveled in air. If this was air only, both travel the same distance. But here, because it's passing through the glass slab, it is traveling extra. How much extra? Mu minus 1 into t. That means, if I have to write distance traveled by the ray from S1 to O, how much will be that? S1O plus mu minus 1 into t. S1O plus mu minus 1 into T. Are you able to understand? Whereas this one is traveling how much? S2O. So path difference at 8, O will be what? S1O plus mu minus 1 into T minus S2O. And since geometrically S1O and S2O are equal, you can cancel them. So delta X will come here as mu minus 1 into T. That means delta X here is not 0. So that means central maxima is not here. So where it will shift? Who's traveling more? The upper one. So what we have to do to make delta X 0? Shift it upwards. Maybe here is your central maxima. Then it will go like this and this will go like this. This will be the position of central maxima. Again, we can find that position. This is Y. Okay, we can find it. See how to find that. Okay. Now, this is central maxima, so again path difference needs to be 0 there. Correct or not? So we already know that. How to find the path difference? I drop a perpendicular again over here. Okay? This is the path difference. This is delta X. And this you can join again over here. Say this is theta, so is this. And again this delta X is d sin theta. And if it is YDSE setup, I can say sin theta equal to tan theta. Okay? So we can say that this d sin theta will be y by d. Correct or not? So this d sin theta, that means you are saying this is traveling. This is traveling more than this one. Correct or not? This one is traveling more than this one. But how much more we want? We want it to be equal to the path this is introducing. How much path this is introduced over here? Okay. What it has introduced? Let's write. I will write it and show you that. This is here only delta X. Actual delta X is you see in this one. What is that? Delta X is, at this point I say it's P, okay? S1P plus mu minus 1 into T minus S2O, or the other way around, okay? S2P. Now, S1P minus S2P plus mu minus 1 into T. Okay, now S2P minus S1P only is this delta X. This is geometrical. Okay, in that one, we are not introducing this slab. So S2P minus S1P is d sin theta. Let's put it over here. So minus d sin theta plus mu minus 1 into T. Okay. Now for first maxima, rather for central maxima, how much should be delta X? 0. Put 0. So d sin theta equal to mu minus 1 into T. And what is sin theta? You know that sin theta we can write as tan theta. It will be y by capital D. So d y by capital D is equal to mu minus 1 into T. That means y value is mu minus 1 into T capital D by small d. Are you able to understand? If this glass slab is there, you have to add mu minus 1 into T in the geometrical path you are going to select. Geometrical path is S1P plus mu minus 1 into T is the total path structure. Whereas for this one it is S2P only. So path difference S2P minus this one or this minus this one. Okay, that's your wish. So this way we are going to calculate the position of central maximum. Okay, that's it for now.